And it's my pleasure to hand it over to Loran, the managing director of iPavlov, one of the best companies in Russia. Dear colleagues, I would like to, Oleg, I would like to thank you for this organization, for an invitation to this conference. We will not talk about the future of AI, not about the present of AI, but about a product we developed that shows that AI is reality. Our world will be based on. It's a product on finding, on smart defect detection. And we will have two speakers from our company. I will start with an introductory word, and then I would like to hand it over to Yegor Kisseliov, representing the development team. And smart detection, defect detection system, we started to develop it a couple of years ago, and it was used in metal industry, in lumber industry, in many companies of in Russia. And I'm happy that today we can present it no longer as an R&D, but we will show you the actual interface used at plants by our users. I would like to start the countdown, to have some flashbacks, to tell you about our journey back in 2019, where we started this iPavlov project supported by Sberbank and the research center of Schwabe at Moscow Institute of Physics and Technology. And we now have labs that develop new architecture and models our company also uses. In our portfolio, we have over 5 business areas, 5 AI platform solutions. We are moving to a mature stage. We raised investment for over 1.5 billion rubles. If it would not have been for the pandemic of 2020, the result could be much higher. So today, many wonderful companies face on the client's image. They want AI to offer unique user experience. But our financial indicators, our revenue is quite healthy. So here I would like to finish my introductory word and hand it over to Yegor Kisseliov. Could you please tell us about the development? Thank you, Loran. I'm really happy to take part in this conference, and I will tell you about our smart defect detection system in metal industry. You will see a short video where we will see how raw metal is produced. As you see, we see coils with metal. They come for production, then they are placed into the machine that cuts the first strip, and then rolling starts at a speed of 1 meter per second to knives that will cut the metal web into sheets. We have 5 cameras above and 5 cameras below with analyzers that analyze the metal sheets for defects. The data goes to the server, 11th server, and then there are messages that go to operators HMI. So, a couple of words. The knives, and then metal sheets are stacked to be later on produced for the passed to the warehouse. So, on the slide, you see a number of different defects. We recognize fractures, cracks, corrosion, emulsion. And we have about 36 defects we need to identify. We need to inform operator very quickly about a defect identified. Another important indicator is waste percentage, because we need to know how accurate our system is in identifying defects and their position. So when we started the project, there were a number of experiments, and we used a number of models and architecture versions. With the most efficient systems were YOLO, SSD, and RetinaNet. We used the fifth version of YOLO, and we used multiple processing, and this combination proved to be the most efficient. We had to reject a number of preliminary developments and a number of techniques due to our limitations on timing to provide the operator data in real time as quickly as possible. And we also used YOLO plus YOLO and a number of other combinations which were better in terms of performance, but slower. It took them 5 times slower to identify defects. And the project actually requires real-time feedback, and we had to fine-tune a number of data, huge number of different data to integrate them into the interface. And it was important to show to the operator the full picture, the full map of role for them to be more accurate in identifying the defects, not to compromise quality, and to stop production as quickly as possible if there is waste. As for the critical defects, they can be different for different batches. And the process should be customized. We should be flexible here. Here, you can see the way our interface looks like. And so this is emulsion, one of the defects. It's very visible. And on the left, operator has the hierarchy of the production of the products relevant, the batch number sheets, and defects identified. So the operator can also use data from the camera that identify them by the number of roll position of the area where it was identified. So also here you can see the map of a roll, zoomed in as much as possible. And here you can move all across the roll and find particular defects that made the supervisor concerned. That means that you can control the production process faster. So actually, I told you a little bit on where our system is positioned in the technological process. Now I would like to tell you with the number of external systems we have to interact and integrate to really integrate it into the production process at a plant. It all begins with sensors, different sensors that transmit readings to our system. They take images, and data is integrated for specific levels and the correct work of CV models. Then data is transmitted into the system, defects are identified, and enriched metadata go back to the tracking system already integrated into the production process that allows to analyze development dynamics at a high level. And it's possible to use two interfaces. One is local, right in front of the operator, that allows operator to know about technical defects. The other one suggests that there is a supervisor that would work the history and the dynamics to assess productivity. That's a little bit about our architecture. The list of all sensors we interact with, cameras, scissors or knives, batch sensor at the end of the rolling line, which does the packing, and we need to interact with it correctly to realize where and what sheet has a defect. As I said, we had 10 sensors with cameras, and they transmit all metadata to server 11 that aggregates the information, which used a number of IPs for the most critical defects to inform the operator to send him the message in real time and to make time needed to process the request shorter. If you have any questions on technologies, feel free to use my contacts at the end of the presentation or ask me a question. Here you see the slide with companies that use our technologies. And as a matter of fact, my part is about to be finished. I can hand it over to Loran for the closing remarks, and I would be happy to answer your questions. Thank you, Yegor. I would like to note that the system is scalable, and from the very beginning we understood that we are creating digital industry, smart industry, and back in 2018 we got a big number of requests from companies for that type of systems. We realized that for big companies it would be difficult to trust their data to IT companies, and it took us 1 year to do the conceptual design of such systems, because we had to taste them and we think on how to integrate them, given all the specific features for integration of such digital platforms into the existing infrastructure. If it would be nice, we still have some time left to go to questions or comments. Well, I realize that we might be able to answer only a few of them, but you have our contacts, so we are really interested in requests, in all sort of interesting proposals. We would be happy to consult representatives of the industry on systems like this one. Loran, Yegor, thank you very much. A very interesting solution. Also, for those who see us, I would like to tell you that you can ask questions using the QR code. And the first question to you, Loran and Yegor, What are the solutions you have for large industrial enterprise? Well, based on AI. What your company offers? Well, a good question. We have a host of inquiries, but we group them in a number of areas. Number one, everything related with road infrastructure, traffic. It can all be integrated as part of smart city. And on the one hand, here the role of industry secondary, like in projects like smart traffic lights or smart surface for driverless cars when it would identify data on weather. It's a special area for automotive and machine building. And next, we have a big number of deployments with EVA, our first product, which went to the market in 2020. It's a possibility to create corporate brain as digital visual assistant used in HR systems, in systems used for decision-making, used in a mobile app or in a widget. You use a voice assistant. You can automate gestures. And there are a lot of services and super services, from some trivial document flow for a business trip, or some smarter solutions for managing engineers, where a smart bot could consult an engineer at complex maintenance works. So the digital assistant can be independent and participate in repairing some complex equipment. So another area, predictive analytics, and no secret for every enterprise that works with a power machine is operation, technical maintenance, and there is a request for digital solutions that cannot just predict failure, but also provide analytical data. So that's about our last trends on what we implement and introduce. Many thanks, Loran and Yegor. Thanks for your presentation.